This video is all about exploring terminal servers, which allow you to connect the serial console ports from multiple devices up to a central hub for access. We'll take a look at my early 2000s MRV secure console server I've been running for over a year and set up a fresh terminal server on a Cisco 2509 from the mid-1990s, octopus cable included. We'll even try to get a modem hooked up to its aux port. Let's get into it. If you're anything like me, at some point along your home lab journey, or actual career maybe, especially if you're into this networking stuff, you're going to find yourself needing to connect to networking devices over a console port. A console port is simply a serial connector that allows you to hook another computer up to the device in question and view it over the terminal console, hence the name. A lot of devices use this RJ45 connector, the exact same connector I'm sure you're familiar with that you would see on the end of this Cat6 cable, for example. And that connector makes a lot of sense if we're thinking about a data center and flexibility. So with not a lot of money spent on tools and about an hour of your time, you can learn how to make these cables pretty effectively. Though I will point out, technically speaking, for these serial connections, you're supposed to use what's called a rollover cable, and it's flat. So you can see all the wires inside, as you can imagine here, are lined up one after the other, as opposed to what's going on in this twisted pair cable. So you can see the twisted pairs are all wound up together, twisted, hence the name. But in practice, I've used Cat6 a ton to make these serial cables, not this flat stuff, and haven't had a single issue. Did want to point that out though. Now, depending on the manufacturer, or more importantly, the time period, you might see this more recognizable console serial port here that you might be more familiar with. But it's just wires connecting to other wires at the end of the day. So you can buy these little adapter guys here and get that converted over to RJ45. But back to lab and infrastructure expansion, you might only have, a couple of these cables. And when you want to go interact with a different device, you're going to have to go to your rack or unplug everything and get back into the right situation so you can talk to the device you care about. And it just doesn't scale. I actually have a concrete example in my home lab right now. I'm sort of in between dial-up setups, and I actually require two routers to be on, one with the modems, one with the telecom stuff, to actually be able to dial into this setup and access the network with modems. So I need both of these on at the same time, and when I'm experimenting, I often want to configure both of them at once. Up to this point, I had been solving this problem with this, an MRV, they call it a secure console server. This is the InReach LX series from MRV. This particular unit was manufactured in 2002. If we take a look at the back, it's got 8 of those RJ45 serial connectors. These are not Ethernet connectors. And I can connect up 8 serial devices to it. On the other side of the back is where it gets interesting. It's got its own serial port for local management. And it's also got a 10100 network interface. Now this thing is what's called an appliance. This thing is running some ancient version of Linux. You can get it hooked up to your network, plug it in. It doesn't have a power switch. When you give it power, it boots up and does its thing and starts hosting some software. It'll pull an IP off your network. And there's actually a pretty wild Java interface that I can use to configure each of these 8 ports, their speed and other characteristics of the serial line. I can also, of course, do that locally over its serial management port. In practice, I don't. I just use the Java interface. It's also got this telco line, which will be interesting to play with in the future. Get this plugged into my analog setup. It's already had an incredible service life. This one was built in 2002, and it had as late as a 2022 audit code from whatever IT department used to own it before I did. So this very cleanly solves a pretty big problem. And it doesn't have to be network devices. Anything that communicates over serial, you can plug in here and get it working as long as the pinout is correct. Which brings me to my number one gripe with this thing. This cable isn't going to work here. For whatever reason, this MRV uses what I would consider a non-standard pinout, or at least one that's not compatible with Cisco, which is more or less the gold standard when it comes to network serial connectivity. But back to the beauty of the RJ45 connector, I made my own cables. I've got them tagged here so that theoretically I don't forget what they're for. And I have got a couple of these Cisco 2 MRV pinout cables that I've made, and that more or less solved my problem. Let's get a couple of things hooked up to port 1 and 2 of this thing, and I'll demonstrate just how awesome it is to have one of these terminal servers around. Okay, I'm at a regular old terminal prompt here, and if you recall from the other clip, I only plugged that MRV secure console server into the network. This computer is in no way locally attached to it. They're just on the same network together. That thing pulls down an IP from my DHCP server. It happens to be 1.53. And now, over telnet ports, it exposes each of its serial ports, starting with 2100. So if I telnet to that IP of the MRV, port 2100, I'm now at the serial console of one of those PIX units. Those are two PIX firewalls. This is CR PIX 1. I can break out a telnet, of course. And now if I just go to port 2200, I'm at the other PIX, CR PDM PIX. The other one was called CR PIX 1. This is such an easy way to very easily get network-based access to the physical console ports. It's been incredibly useful in my home lab. And of course, you can just, start up a new tab and bam, you're in. You can have as many tabs as you need open. Incredibly useful. I suppose I should show you the Java GUI interface. So you hit it in a web browser. Same IP we were hitting it over Telnet with. The username is inreach, one word, camel case. Password is access in the factory default configuration. So you can tell it's good because it's processing XML. It froze. We're going to switch over to Firefox. I play around with Java versions all the time, and if you don't have things lined up with this old stuff, it doesn't really work out. But we can go over to ports, async ports, and here we can configure in great detail each of those RJ45 serial ports. In practice, I hardly ever have to use this. I occasionally need to change the baud rate on one of the ports when I'm messing around with something that's not the typical 9600. So yeah, it's all here. It's pretty nice. It's quite the enterprise package. I can't complain about this MRV unit other than that funky pinout. I'm going to leave this thing in service, but it got me wondering, what was Cisco's response to this terminal server problem? And then I started getting wind of some really interesting stuff. If you start doing research about Cisco terminal servers, the Cisco 2500 series is going to start coming up. Now, these things have been around for quite some time, the early to mid 90s, I think. And of course, I don't think it's recommended to use these in a production environment today, perfectly acceptable for home lab use. That being said, as with any enterprise networking equipment, I would not be surprised to hear that there are probably a ton of these still in service. And I'm sure you noticed, I have two for some reason. If we flip them around, we can see the one on the top is a Cisco 2501, and the one on the bottom is a 2509. And the only reason I got interested in these things in the first place is because of this, an octo cable. It is a async serial breakout cable that breaks out into 8 RJ45 connectors. And the other name for it, which is far superior for obvious reasons, is a squid cable. Or perhaps even more obvious, octopus cable. 8 legs. Now this is clearly a purpose-built cable from Cisco to break out one connector on the back of one of these guys out into 8 devices the same way that MRV console server was being used. But if we flip to the back again, we can see the one on the top isn't quite as well endowed as the one on the bottom. So in my haste, I bought this thing on eBay weeks ago. Not disappointed with that purchase, obviously. And then I wasn't paying enough attention and I saw a good deal on a 2501. This is just a router. It is not meant to be used as a terminal server. You can see it is missing the obvious async 8-port cable breakout plug that I need. But by sheer coincidence, a viewer named Vit, I hope I'm saying that right, reached out with a pile of Cisco gear. This 2509 terminal server was part of the lot. It came all the way from the Czech Republic, which is awesome. So a huge thanks to Vit, kind of saving the day and making it so I could actually set this up and leverage these things. And because of that same lot that they sent in, the 2501 is not going to be a total loss. We do have another octopus cable, seen tons of use. You can get some of these with like 16 ports. So you can plug 2 of these in. And then a bunch of these serial breakout cables. So this one goes to that type of connector. Another DTE serial to this sized connector. And then my absolute favorite, serial connector again to this prehistoric monster. Just look at that. I don't have anything to plug this into, but I tell you what, I'm gonna find something. So yeah, I'll be putting this thing to some sort of use once I decide what that use might be. Let me know if you have any ideas in the comments. Maybe some ISDN stuff? I really don't know, but I've got a lot of good cables to try out. But in the meantime, let's turn our attention to the squid. Now, I believe there are several ways you could configure this terminal server. One way is you can see it in turn has its own console port. I could have a machine hooked up to this, and this thing could give me access to one of the 8 ports I care about here, and that'd be okay. But I'd much rather have it work the same way that MRV does. I'd like to have this have an IP on the network. I don't deal with this console port at all, and I can just telnet in directly to these lines, and I believe that is a configuration I can get going here. But you're going to notice there is no obvious place to get this on my network. It does have Ethernet though, in the form of an AUI, or Attachment Unit Interface port. This is an antiquated port even by mid-90s standards. I think it was 10 base 5. So what you do, I think, is you get converters. At the same time as I got that router that doesn't have the octopus cable interface, I had picked up these because I thought this was going to happen, and then this other very similar but slightly bigger unit was included in the lot with the 2509 on the bench here. And these are really impressive. Like, they're metal and they're hefty. These are clearly like very well made. I've never used them. I'm not entirely sure these are even going to work. These are MAU 10 base T. I hope they can convert from AUI. We'll find out together, I guess. These AUI connectors are pretty interesting. They've got this latching mechanism. It goes left and right like that. And my transceivers don't actually have any pins in them. That's how they came from eBay. But the one that came with this has these shoulders, little pins that are in there. And you actually plug this in and you can slot that guide over. It's kind of tricky, like that. And it's actually latched in there. I mean, it would absolutely break off with very little pressure. And it's my understanding that that was one of the complaints from these things. I mean, obviously, you know, this is really easy to bump up against, especially if it's hanging off a rack or something. But yeah, I've never actually messed with any of this stuff. So it's kind of cool to see that latching mechanism. I wouldn't have known about that unless I got one of these that had these little pins. Okay, we're all hooked up. We'll get everything configured in here at first. I don't know the password situation on this thing. Hopefully it's just factory reset, but we'll figure that out. This is just gonna go into my network, and this is a serial connection directly to a computer in the room with me. So, never turned it on before. I'm already seeing something on the console. It's not very loud. This thing's doing stuff. Little adapter's got every light on. Power and link. That's got to be a good sign, right? It's up. Do we have admin access? We do. Let's see here. iOS 11.2 from 1997. Good enough for me. Just issued a show line there, and you can see it knows about the 8 different serial ports that cable is providing, so that's exciting. Right, assuming that's what these are. We'll find out. So Ethernet 0, of course, is not configured. I don't know if that port I'm plugged into is actually connected to something that can auto-negotiate to 10 base T, but we'll find out. Terminal, let's do interface Ethernet 0. We're going to assign it this IP on my existing network. Bring it up. Not convinced it's going to work. Let's do show IP int brief. It thinks it's up. Let's ping my router. Yeah, okay. Well, that part was easy. Something really cool about using these adapters. I'm sure they were a huge pain back in the day, but something fun about using something so well constructed. Like, these are just so nice. I'm not saying this is like primo technology here, but clearly a lot of effort and money went into these little transceiver things. Been doing a little bit of research to figure out how to configure this as a terminal server. Step 1, I think, is I'm going to issue these IP host commands. So I'm going to name them D1. A lot of the documentation and tutorials you see, they'll call them router 1 or R1. I'm using D for device because I don't know if I'm going to plug routers or switches or whatever else in here. You give it a port and then the IP. This IP is what I gave our AUI interface there. I'm just going to go down the line and do 8 of these. I think you get the idea. So that's done. Now I'm going to look at some configuration I found online, of course. So I'm going to configure lines 1 through 8. That's my squid, my octopus cable. I'm going to basically disable timeouts. So if someone connects to one of those guys over serial, someone being me, of course, I don't want it timing out after a minute or whatever. A lot of the time I'll walk away or I'm Googling something. And then I threw a couple more on there that you can Google yourself. I don't even know if they're necessary, but found them in a tutorial and we're going to find out together if these are going to work. Okay, I got these PIX firewall units back out for testing. I've connected tentacles 1 and 2 to these guys, so let's fire them up, see what we get. So it's my understanding that I should be able to telnet to the 2500 at the IP address we gave it on our little adapter, and then port 2001 should be the first wire of the cable. This was too... Folks, this was too easy. Yeah, this is... Obviously, we're at the PIX. So, let's get out of here. And then 2002 is the other one. Yes. I love it when something just works and it's easy and it's logical. Hopefully it's been easy enough to follow, but just to reiterate, if we telnet to the IP address we gave this Ethernet interface, and we hit port 2001, we'll get cable 1, 2002, cable 2. We saw that in action with these two guys. And of course, on down the line. Cable 5, it's nice, these are actually labeled, which is nice. That would be a nightmare. Cable 5 is port 2005, and so on. So I think we're ready to get this racked up. Every time I start using a new series of router, I really start to like it. I guess I'm glad I have two. It'll be fun to do something interesting with that other one. Well, this thing is perfectly functional, which is great, but you might have noticed before it's missing its nice Cisco badge, and that is because it did not survive the trip across the Atlantic Ocean. It popped off and then got crushed, unfortunately. So let's see what we can do about that. I was able to find most of the pieces in the box, except for one sliver here, which is sort of odd. I mean, it must be in my house somewhere. I'm assuming this was intact when it was shipped. But yeah, I'm going to try to glue this back together best I can. And that little piece is just going to be part of this guy's history. Not perfect, but it's better. It's good enough. It actually looks kind of cool. You got to respect these old machines. They're hard workers. Never forget to write out your configuration. So everything I just got set up was lost because I turned the router off without writing it out to memory. So these Cisco units are kind of interesting in that if you're configuring them, so for example, let's say hostname, and let's start calling this thing termserve. Its hostname is now termserve. It's not router anymore. It's live immediately. The moment you type it in and press enter, whether you did the right thing or not, it's live on the router. But if you reboot the router, it's going to lose it unless you save the configuration with something like the WR command to build it and write it out. So I'm usually pretty religious about that, but I just lost it. Maybe other network equipment is like this, but it's kind of interesting. You do get used to it. It is nice to see it go live immediately. So I've rebuilt everything. So I can say show host. You can see I've got D1 through 8 for device. And let me show you how a lot of tutorials and a lot of folks are going to be using this. So I'm still connecting to this thing over the serial console directly, as you can see. And there's a lot of other goodies in the picture here that we'll get to very shortly. So let's say I wanted to connect to that PIX. I've got that on cable 1. I've called that D1. A typical setup is you're consoled into the terminal server, and I can just hit my host name, and bam. Now I'm on the PIX. I can do whatever I want to it, and I'm all good. Now the way you get out of this in the Cisco world is Control-Shift-6, let go, hit X. You can see now I'm back on termserve, but if I start trying to do anything or press enter, it hops me right back in to the D1 connection, which happens to be this PIX machine. So what you have to do is Control-Shift-6, X again, and you type disconnect, and it'll confirm that you're done, and now I'm back there. I just wanted to show you that because a lot of the tutorials you're going to see about this stuff are about using it this way, whereas I have decided to put it on my network, and I'm going to rarely ever, console into this and edit it this way. Theoretically, since these are just serial lines, you could connect 8 modems up to this octopus cable. And so I started kind of playing around with that. I can't actually get it to work on one of these lines. And that's not really the point of this video. Probably just don't have the right dongle, believe it or not. But it did get me really curious about modem interactivity with these routers in general. So I got this US Robotics unit, a Sportster 33.6 fax modem. This came my way from a viewer named Larry. Thank you so much for sending this over. And even though I couldn't get it hooked up to the squid cable, a lot of Cisco units come with an aux port that isn't really talked about very much. And the deal with it is you can hook up a modem to the aux port to allow another form of remote management. So like last case resort, remote dial up into a modem hooked up to the aux port and configured correctly so you could dial in off the telephone network. We're not going to cover that thoroughly today, but we are going to attempt to interact with this modem and actually dial out with it. So we're going to have to talk through a few things for this to make sense. This gray line is going to those Cisco routers I was showing earlier in another room. They're simulating a telephone network. And then of course I've got this phone hooked up to the phone line in the modem. So we've got a dial tone. That's all good. Out of the aux port, we're coming back into this monstrosity. So this is just the rollover cable. You've seen those in the video. And then we've got RJ45 to null modem adapter, mini gender switcher, DB9, DB25 that the modem needs. And this of course just works. Gotta love it. A normal setup might have some more specialized equipment and not as many dongles. Back configuring the terminal server, we're going to do a debug conf modem. So these Cisco units have a bunch of debug flags you can turn on, and they give you more verbose output about a particular thing. In our case here, we care about modem configuration database. More on that later. Then if we do show line, we can see that our aux port is called line 9 right here. So we can configure the terminal, go into line 9, a couple basic setup things, flow control hardware. We want modem in out, transport input all. And then I found a fancy article from Cisco themselves that says I can do a modem auto configure discovery. And what this is going to do is actually go try to figure out what type of modem this is on the line. So you can see it's doing its thing right now. And I suppose depending on your iOS version, there's a database of known modems, and this knows a USR, US Robotics Sportster. So it sees it, which is great. Now, as with any other serial device, we should be able to telnet into the modem and actually tell it to do stuff, which is kind of interesting. So if we do a show line again, the way the Cisco stuff works is all these async lines start at port 2000, and then you add the number you're seeing here in line. So if I want to telnet into side note, you can see it reconfigured this to the max speed of the modem, which is 38400. That's pretty nice. But we can do a telnet this router 2009, and we're in. And theoretically, we should be able to issue a modem command, AT-dial, and then a number on my telephone network that is being hosted by those other routers. And we should hear some stuff happening on the modem. I keep dialing the wrong number. So as you can see, I didn't have the mic going for this one. This is the wrong number because there's a 7 here. Anyway, 425-271-5555. Let's try that again. So yeah, it says we're connected, and then we're getting data back on the screen. I don't really know what I'm going to do with this setup yet, but like and subscribe. More of this coming. Obviously, I wasn't doing anything productive with this modem yet, but now that I have a little idea of how that even works, it'd be very interesting to build like a backup analog telephone network to all my, mission critical Cisco gear down here. Anyway, more to think about. I think I'm finally ready to move this thing out of here and get it in the rack, and I'll show you how that's looking. These things get a little warm, by the way. Maybe that's why they're made out of metal. Some sort of heat sink action going on in there. Got a little stack building up here. Cables 1 and 2 are going into my dial-up setup, which requires 2 Cisco routers at the moment. Cable 3 is actually going back into the 2509 itself in some sort of terminal server inception. So we'll see if we can telnet in to itself from itself. And then we've got a newcomer on top. This is a Cisco 2900 XL series. I have never been able to access the console port on this thing from my MRV unit. So we've got this plugged in to cable 4, and I'll see if we have better luck with the Cisco terminal server. Let's see if all this stuff's working. We're gonna go on down the line. Wire 1, let's see here, router. I should really rename these. See who we are. The 2900 series, so this is the one pretending to be a telephone network. Very nice. the next one, the 2600. This is the smaller one with the modems on it. The moment of truth. Line 3, or port 2003, should be the terminal server itself. And we're in. We can manage it from itself. Anyway, not gonna think about this too hard. Love it. And then I have never been able to remotely manage this 2900. There we go. Yeah, we're in. This thing did not like that MRV. I could never do this. So this is working great. Well, I hope it's been clear that I'm just getting started with that terminal server. You'll notice it wasn't actually racked up in the rack. My rack is getting a little busy. I've got a bunch of stuff I need to run, you know, for my actual just modern network and home. And then I've got tons of old networking equipment I'd like to rack up, tons of old enterprise servers I'd like to rack up, and I'm just out of room. So I'm probably gonna have to do something I told my wife I would never do, which is increase the height of the rack or get another one. So I kind of want to plan ahead. It kind of defeats the purpose if you've expanded beyond the length of this squid cable and you only have so much on it. Is it a squid cable or an it's probably an octopus cable. I keep saying squid, it's probably octopus. And can we take a moment for this thing? Just look at this. It doesn't get any better than this. But there's a lot more to explore. We only just scratched the surface on what you could possibly do with modems. Again, a huge thanks to the folks that have sent this stuff in and enabled me to be able to explore and rediscover all this stuff from the 90s and early 2000s. I've got a lot more ideas and a lot more content like this on the way. So if you like what you saw and you haven't already, please consider subscribing. And if you'd really like to support the channel and enable me to get a lot more stuff like this, I'm on Patreon. I post behind the scenes type footage, early access videos, and you'll get a general idea of what I'm tinkering with. Like this thing that I bought on eBay last night. These terminal servers are super interesting and it still solves a problem today. Cisco still makes them. There's obviously open source ones. You could just get a bunch of USB to serial adapters if you really wanted to in like a Raspberry Pi. But it's been really fun to explore the ones from the early 2000s and, in my case, mid 90s Cisco servers. Thanks for watching, and I hope I see you in the next one.